Have you ever suffered from resource pain overload? You know the feeling. It's when you have too many image files in your Hype project and no easy way of organizing them. Or worse, you have a lot of graphics that are essentially minor variations on the same theme, just slightly different sizes, colors, resolutions, or different image formats. Just imagine if there was a way to clean up your resource pain and reduce the number of image files to just one while still retaining the ability to resize and style individual graphics no matter where or how often you use them. Better yet, you could do this while harnessing the resolution independence and infinite scalability of SVG images. And if I told you, all of this was possible while decreasing the footprint of your app and potentially increasing its performance, would you believe me? Probably not. But all of this is possible using SVG symbols. These symbols allow you to reuse, resize and style individual SVGs derived from a single file in your resource pane. You can do this while retaining the ability to modify an image each time you use it. And by doing this, the performance of your app will be better because it will require fewer HTTP requests, and file downloads will be smaller. And you'll make better use of file caching in the browser. Are you interested to learn more about these symbols? If so, then let's get started. In the rest of this video, we'll go step by step through the setup, construction, and use of SVG symbols in Hype. I think you'll be surprised at how easy and powerful this approach can be. Let's get started by looking at a simple example of how you might employ these SVG symbols. Here is an emoji icon library that I want to incorporate into a new app. I've created it from many separate SVG files. I could load each of these SVGs into the resource pane separately and then drag one onto the canvas whenever I needed to use it. Under these conditions, the resource pane looks like this. It's already starting to look overcrowded. Alternatively, I could combine those original files into a single SVG file where each vector is now a symbol. Then, I could make my canvas appear the same, but there would be only a single file in the resources panel. That's nice, but here is the neat part. Since I've placed the same underlying images on the canvas as symbols, I can now resize or restyle each instance in a custom fashion. For example, here is the same layout of emojis as before, but now I've changed the stroke or fill in some images. I could go further by taking a single symbol and customizing it in several ways without changing the underlying template image. You can achieve these customizations in two ways, using SVG presentation attributes or by manipulating properties of the Hype element that contains the symbol. So, at this point, you might be wondering whether using SVGs in this way works reliably across different browsers. When we render our simple example from earlier in a browser, you can see it works fine. And then if we do the same test in each of the main browsers, it also works as expected. While some minor inconsistencies exist in how the different browsers implement SVG presentation attributes, there are no big showstoppers. And in general, using SVG symbols is a very robust technique. So how do you make and use SVG symbols in Hype? Well, I've broken it down into a 6-step process. Fortunately, there are tools to automate this process, and I'll show you these later. But first, it's important to conceptually understand what each of these steps does so you can adapt this process to your own project needs. The first step in this process is to create an enclosing SVG. You can do this in any text editor. I prefer Visual Studio Code, but any editor will work. Just remember to save your file with a .svg extension. The syntax for this enclosing SVG is very straightforward. It's essentially the same syntax that's used to define a regular SVG. This involves adding a pair of SVG tags and a namespace attribute. And that's all you need to set up your symbol file. The next step in this process is to take the code from an existing SVG image and paste it into this framework. I've done this for one of the emoji icons we saw earlier. This SVG code must include a unique identifier. I've used emoji-happy here. This ID will eventually become the fragment identifier we use to refer to this symbol when we insert it into Hype. This identifier looks similar to those you might have seen in the regular DOM. But it's not. Instead, it's just a way to refer to this vector inside the namespace we created with the encompassing SVG. Specifying a title as part of this SVG code isn't absolutely required, but including it will endow this symbol with a minimal tooltip whenever it's used in the future. This can be helpful in some circumstances, but feel free to omit it if it doesn't align with your project goals. To turn this SVG inside another SVG into a reusable symbol requires one more step. That step is changing the inner SVG tags into symbol tags. Like this. We'll make this change manually for now, but I'll show you a way to automate this conversion later. To add additional symbols to this library is just a matter of pasting in further vector descriptions, changing their tags, and then adding a unique identifier. Like this. Now we're ready to use this symbol library in Hype. The first step in that process is to import the SVG file containing your symbol library into Hype's resource panel, just like you would do for any other file. Next, we want to add a symbol from this file into a container element on the Hype canvas. To better see how this is done, I'm going to zoom in on the Hype interface. To make that SVG container, you need to generate an empty Hype element and add some further code into its inner HTML. That element can be a simple Hype shape without any border or fill color. I usually choose a rectangle. I've already done that for each of the emojis in my library, and I've opened one to show you the end result. The simplest way to access the inner HTML of an element in Hype is to click directly on the container. Once you do that, a small button pops up at the base of the rectangle. That's what I've done here. Usually, clicking on this button pulls up a blank dialog window. Into this window, you can potentially paste all kinds of HTML, CSS, or JavaScript code that help define the appearance and behavior of this element. As you can see, I've already pasted in some SVG code for the tongue emoji. So the trick here is embedding SVG code directly into the inner HTML of a blank element. The other ways you can access this inner HTML dialog are from the Edit menu, using the option labeled Edit Elements Inner HTML, or by using the keyboard shortcut, Command, Option, E. So now, let's look more carefully at the SVG code I've added to the Hype container. It uses the familiar SVG tags and namespace attribute that we saw before. It also includes a viewBox attribute. This attribute should contain 4 numbers that define the coordinate system of your vector image. It's important that you define a viewBox so that your image will fit snugly inside and scale with your Hype container. However, the exact numbers aren't crucial, provided they describe a shape that matches the dimensions of your image. Inside your SVG tags there should be a pair of use tags. These tags are where you insert a reference to the symbol you want to be displayed. There are 3 parts to this reference. Firstly, you need to indicate where the symbol file is. In this case, it's in the regular Hype resources folder. Next, you need to identify the particular file that houses the symbol. In our case, that's symbol-defs.svg. And finally, you need to give the fragment identifier that points to the actual symbol inside the file. Here that is, #emoji-tongue. Once the symbol is displayed on Hype's canvas, we can resize or restyle it using either presentation attributes on the SVG or native Hype styling of the underlying container. You can also combine these methods in any number of different ways. I'll demonstrate just a few here, but there really are a lot of possibilities. For this, I'll use the grinning emoji example you saw earlier. Provided your symbol has a viewBox attribute, no additional code is required to resize it. You just simply resize the Hype container that houses the symbol. You can do that interactively at design time by drawing out the container's corner points. Alternatively, you can change its size dynamically at runtime by using Hype's regular animation capabilities. To change the color of a symbol, you can add new presentation attributes to the container SVG. In this case, I've applied a different color to this emoji by adding a new fill attribute, here. Adding an attribute in this way can add properties absent from the original symbol or override a property that already exists. There are many potential presentation attributes that you can choose from. However, some of the more advanced SVG properties have inconsistent browser support, so it is probably best to stick with simple attributes like fill, stroke, opacity, etc. For more information on these presentation attributes, check out the website shown here. An additional way to change the color of a symbol is to manipulate the properties of its container. I've done that in this example by adding a gradient fill to the Hype container and then rounding its corners to match the shape of the symbol. Changes like this require no modifications to the underlying code, and potentially can also be animated by Hype, giving you still further flexibility. And that's it. Now you know how to make an SVG symbol, add it to the Hype canvas, and then resize and/or restyle it. From here, you can animate it in precisely the same way as a regular Hype asset. Manually constructing an SVG symbol file might seem like a lot of work. Fortunately, there are quicker ways to make these symbol files. I'll highlight 3 kinds of online tools here, but there are many other possibilities. The most basic kind of tool is a simple SVG to symbol converter like the one shown here. This tool takes an existing SVG, converts it to a symbol, and then outputs both the symbol itself and code you can paste directly into a hype container. More helpful tools take a whole library of SVGs, converts them into symbols, and then outputs them into one large sprite file. In my experience, the best tool available at the moment for this is the one shown here. And finally, some image vendors will let you take existing collections, or custom selections of their SVG images and bundle them directly into one large SVG sprite file. In my experience, the best available service of this type is the EcoMoon app. This app currently has a free tier that fulfills most needs. Its URL is shown here. When we include many SVG symbols in a single file like this, we are essentially making an SVG sprite sheet. This sprite sheet is loaded once, hidden, and cached in the background, making each symbol available when needed. But before we move on, I want to mention the differences between these SVG sprites and old-style image sprites because they are quite different. An image sprite is basically where different graphics are laid on one sheet, and you tweak your elements with CSS or JavaScript to show the appropriate image from that sheet. If you remember those PNG sprites circa 2005 to 2015, you already know what I'm talking about. But SVG sprite sheets are different and better in many ways when compared to these image sprite sheets. This is because individual SVG images can be referenced by a fragment identifier, their IDs, rather than by a pixel position. What's more, individual symbol instances are much more flexible because they can be resized and restyled with SVG presentation attributes. It is important to note that there are some things you can't do with these presentation attributes. Specifically, complicated SVG files with many complex definitions, effects, gradients, or masks shouldn't be used in this way. This is due to the uneven way that different browser types treat or ignore these parameters. In most cases, such complicated SVGs aren't candidates to be reused and restyled anyway. In these cases, you should just reuse the image without making it a symbol. There are also some other limitations regarding clipping masks, but you can overcome these by manipulating the view box attribute of each instance. Given that these SVG symbols are a very lightweight and reusable image format with built-in capabilities for resizing and restyling, you might be wondering what kinds of hype projects are they best suited for? Icon systems and games with many repetitive elements are 2 obvious use cases. Take for example, this card game I'm working on. It includes a relatively small number of graphics that are reused in many different ways, on different cards, in different suits and at many different sizes. But a single SVG symbol file of just 53 kilobytes is sufficient to contain all the necessary images no matter how large or complicated this project becomes. And, of course, it does so without cluttering up your resource panel.